Morning. Assalamualaikum. Previous week we had done with the integration, trapezoidal and Simpsons, and unequal segment, right? Okay, so today I will proceed with Romberg integration, where Romberg is the advance of the previous topic. Okay, Romberg is an extrapolation formula. Previously, we do interpolation, right? Now, Romberg is extrapolation. It integrate out of the range, not out of the range. It integrate in, yeah. If trapezoid, we go in segment, right? Let's say trapezoid and Simpson last time. Trapezoid and Simpson. Okay, we go down, increase segments, right? Okay, as we increase the segment, the integration, it will be more accurate, right? Integration will be more accurate, approaching to the true value. Okay, this one is trapezoid and Simpsons. We go vertically. The more segments, the more closer the value to the true value. Okay. Now for Romberg, we go vertically, sideways. In Simpsons and trapezoid, we do one-time integration. Right. We use either trapezoid or Simpson. They have their own specific equation. So one-time integration. For Romberg, we do second level and third level integration. Okay, but we only use Romberg equation. Okay, I go slide by slide. I explain the definition and the concept first before we go for example. Okay, last time we know when you have a function and at a given range A and B, you will need to find the area under the curve. Okay, that is the integration. Now, in trapezoid Simpson last time, to find the integration, we find the integration value using either trapezoid or Simpson. And then plus the truncation error. This one is the truncation error. Truncation error, the one that you calculate ET TV minus the approximate value. Okay, not the percentage, the value only. Okay, that is truncation error. So that truncation error plus the integration that you calculated, you will get the actual integration, right? Okay. Now H here is according to your step size. H is the step size because you will have different segment, different step size, right? Okay. Now let's say we have two estimation where you have first step size and second step size. Remember, let's say you have N1 and 2. No. 2 and 4 lah, sorry. Easier to... Okay, let's say you have segment 2 and 4. So here you will have your H1. Right, from the given range. How to find the H again? B minus A over N. Okay. H1 is not the same when you have 4 segments. So if you have 4 segments, you will have different H value, smaller value of H, right? Then the integration value will be more accurate, closer to the true value. Okay. Now here, if you have integration, this part for first H, let's say this one integration for n equals to 2. This side integration for n equals to 4. Total integration is same. This one same range, between the same range. Let's say A to B. From A to B, from A to B. All of this is area under the curve integration. Okay. If let's say you have n equals to 2, so this is your area under the curve. Similar when you have 4 segments. Okay, if you have 4 segments, so still the same area under the curve. Okay, that's why I for H1 plus the truncation error is equal to IH2 plus its truncation error. Because both of these, we want to find the area under the curve. Okay. Okay, up to there. Now, here you have this one. When you calculate, you will only have one H to find one integration value, right? But if you combine 2H, let me make it bigger. Wait, the equation lari already. Okay, when you have two hydrogen, sorry, 2H, 2 step size. So here is integration for step size 2 plus combined together with integration when you have step size 1. So they combine both integration. From combine both integration, then you will have this final equation. Okay, when we combine, one time combine, the level of integration is OH4. If one time integration just now, I go back to here, I go back to the previous slide, is if one time integration, this one is level OH2. Okay, the derivation, how to get this, it is in the textbook. Okay, you can read for your own understanding because I will not go further how to derive this. You just remember one time integration OH2 first level, then second level integration is OH4. From the value of the second integration, we combine, you will get OH6. Later you will do example, then you will understand more. Now I introduce you the equation first. Okay, M and L over here is more and less accurate estimates. Meaning that if you have N, this one has, let's say H1, okay, has different H. So H2, which is smaller compared to H1, right? Then it will be more accurate and closer to the true value. Okay, here you have your I1, I2. Okay, so I2 is closer to the true value. So I2 over here will be your IM. IL over here will be the I1, the previous one. Okay. Combining from OH6 just now, you will get OH8. Okay, but up to your level, usually the question I will ask up to OH6 only. Okay. Now this is the Romberg equation. This is the equation IJK. Okay, JK over here means this is the first integration, level 1. K equals to 1. First level, where O equals to H2. Okay. Now this is the integration that you use trapezoid equation to integrate. First level, you use trapezoid equation, whether it is single or multiple. Okay, in Romberg, we use trapezoid only. We don't focus on the Simpson. Okay. Now here you will have the value I 1, 1. First level, K is the level. J is going down sequence. So I2, 1. I3, 1. I4, 1. The J is the sequence in that level. K is the level of the integration. Okay, K, level of integration. J, segment, the sequence. Okay, J going down, K moving vertically, sideways. Then, from there, using Romberg, okay, using this equation, we will find for K level 2, which is O level H4. Okay, to find this level 2, no more trapezoid equation. We use this Romberg equation. Okay, where both of these, I11 and I21, remember, more accurate and less accurate just now from the equation. Okay, go back to the slide. For OH2, sorry, OH4. Okay, H2, H1, M, L. More accurate, less accurate. More accurate means H, smaller H. Okay. Okay, so this one, I11 is less accurate. I21 is more accurate. Combining these two, you will get for level 2. I1, 2. This level 2, K2 and above, we use Romberg equation. Okay, first level only we use trapezoid equation. Okay, combining 2, 1 and 3, 1, you will get I 2, 2. Then 3, 1 and 4, 1, combine these two, you will get I 3, 2. Okay. Any questions so far? Okay, we go to example. This example from the textbook, it used the same function as we did in trapezoid and Simpson last time. Okay. Range is still the same. Okay, last time, for example, single and multiple application of the trapezoid yielded this result. Segment, increasing segment, decreasing of H. Okay, then you see the integration value, which is approaching to the true value. True error, you see, decrease. Okay, the more segment, error percentage also decrease. Okay, this one from trapezoid last time. Make it bigger. Okay, now it asks you to use equation 22.5, which is this one. Okay, Romberg, to compute improved estimates of the integral. Improvise. This value, the one that calculated using trapezoid, is level OH2. K equals to 1, level 1. Okay. Now it asks you to use this equation. This equation is level OH4, which is K equals to 2, level 2. Okay. Now using the equation, 4 over 3 multiplied by IH2. IH2, this one, more accurate. Okay. Now we focus on 1 and 2 first. IH2, so this one, more accurate minus less accurate, this one. Combining these two, you will get I12. Okay, 4 over 3 multiplied by this value minus the less accurate value. So you will get this. From the error percentage at level K2, level OH4, you see the percentage reduced to 16.6. Okay, in comparison, this one goes horizontally. Okay. First integration, you get 89. Second, you get 34.9. This one go down horizontally. But if it go vertically to the sideway using Romberg, second integration reduced to 16.6. Okay, same step for segment 2, n equals to 2 and n equals to 4. This one, I 4/3 multiplied by the more accurate. So more accurate is this minus the less accurate, this one. This is more accurate, less accurate. So these two combined, you will get I2, 2. Integration number 2 for level 2. Okay, you'll get this value where you can see the true error now reduced to 1%. If we do only first level of integration, you will need to increase the segment vertically. Vertically like this, vertically. So you need to increase the segment vertically, then only you can reduce the error. Okay, but using Romberg improvised integration, we move horizontally. Sorry for the term. Horizontally. Okay, so when you go horizontally, it reduced significantly. The error reduced. This one first level. Okay, here you can see the difference just now. First level, this is the value. OH2, K equals to 1. Okay, from the first level, we move sideways to second level where OH4. For C here, up to, sorry. It increased the segment. Okay, so it increased the segment. Moving sideways, second level of integration, then it gets this value for the I3, 2. Okay. Now you see the difference when it moved to level 3. K equals to 3. OH6. Focus on this part. Since this one, not enough data. Sorry. We move to this set of data. These two will get this value. These two value, you'll get this. These two value, you'll get this. Okay, now here, level 3. This value will be 1, 1, 3. I13. Okay, and this one, I23. And it is already approaching the true value. Okay, for O level 6, you use the equation just now. Different equation. For O level 6 here, equation that you should use is this. Not the 4/3 anymore. First level trapezoid, be it single or multiple. Level 2, level 2 is this equation. So moving to level 3, you use the third level equation. Where this one actually is from the Romberg equation just now. Okay. Okay, I move to example. We try this example so that you can understand better. Let me know if I go too fast. Is it okay? Now we go step by step. It asks you to find the definite integral for the following function. This is the given range. A is 2, B is 4. Okay, so from the function over here, just this part. Within this range only. A and B. Okay, the function is square root x. This is your fx. Now here it already provides you the table. So using segment 1, 2, and 4. From the given segment, first thing you need to find the h. Here it is already given. Okay, remember first step is always to find the h. Now for integral OH2, here is K level 1. Level 1, we find the integration using trapezoid. Okay, trapezoid equation. So here segment equals to 1, h equals to 2. So using trapezoid, this one is single application, N1. Okay, N1. Wait. Okay, wait, I'll guide you the step by step. Okay, first thing, just now, H. We need the H. Now, second step, this one is first step, the H. Second step is to identify the data. What does it mean, identify the data? Here means, remember we need, here is I11, I21, I31. Okay, for level 4, I12, I22. Okay, all of this, we need the axis and f-axis. To find the integration over here, we need to remember to use the trapezoid. We need the f-axis over here. Okay. In order to find the f-axis, we need to identify the axis first. The point that you want to calculate. Okay. Here, sorry. Now for n equals to 1, h is 2. So here it involves XA and XB only, right? The point. Okay, n equals to 1. XA, XB only, correct? A, B. Your A is 2, B is 4. Okay, what is your FA and FB? $1.4142, correct. FB, 2, correct? 2. Okay, this one is n equals to 1. Now, when increase the n, n equals to 2. H equals to 1. N equals to 2, you need how many data points? 3, right? So 3 points. How to find the third point? How to find the third point? We need the middle point, correct? Remember, two segments. So we need this middle point. Okay, how to find this middle point? A plus B divided by 2. Okay, correct? What you get? That point. 3. Yes, 3. Okay, so this one, I'm using the same label as in textbook where it use M1. Okay, M1. Midpoint number 1. So M1 is 3. Find your FM1. Correct. 1.732 1. Okay, that one is for n equals to 2. Okay, now n equals to 4. N equals to 4. So you will have 4 segments. We have identified the M1. Now M2, midpoint number 2, and M3. What is your M2? Okay, as you can see over here, we have obtained our H, right? In the first place, for segment 4. 4 segments. H is 0.5. So M2, to get M2, A plus the H. What is your M2? Correct, 2.5. M3? Yes, 3.5. So what is your FM2? .5811. FM3, 1.8708, right? Okay, up to there. Any question? Anyone need me to repeat? Ruben, okay? Can you get the concept to find the M? Okay, can I move? Now we had identified the data that we need. Next step is to find the integral for first level using trapezoid equation. Okay, I copied back the data that we have just now. Just copy this one. Okay, next step, step 3, to find the OH2 integration. K equals to 1. Okay, how? Using trapezoid equation. Okay, for the I11, level 1 just now, where N equals to 1. Okay, using trapezoid. Single application. So H multiplied by FA plus FB. Okay, H here is B minus A over N. Try to calculate what you get. Make sure you take the correct figure, FA, which is this, and FB. Okay, the H from the earlier part, H here equals to 2. What you get? Sorry, here, 2, right? 3.4142. Okay, next find for N equals to 2. I21. Here it involves multiple application, where you have the equation would be H multiplied by FA plus 2. Now, here is the midpoint. Which data that you require? M1, FM1, FM1. Plus FB, the final value, FN. FN equals to FB. Okay, then over 2. What you get? $3.4392. Continue the same when n equals to 4. So here is I31. Multiple application. H over here referring H at n equals to 4. Okay. What you get? Alif, what you get? 3.4456. Okay. 3.4456. Now that is OH2. The first part. K level 1. Okay, moving forward. Now, next step is to find the OH4, integration level 2. Okay, K equals to 2. So now, integration 1, 2, level 4. OH4, K level 2. Where the equation, it will involve 4 over 3 IM minus 1 over 3 IL. Okay. Now IM over here involving this value I21. IL is I11. Rabia, what you get? Correct. 3.4475. Okay, try to find for I22. What you get? 3.4477. Okay, around there lah. 77. Just now we are given the true value is 3.447715. Okay, true value. So at level 2, integration K2 OH power 4, we already can obtain similar to the true value. Okay, any question? Try to find level 3. Can you find level 3? OH power 6. What you get for I33? One extra. I13. Same. 3.016. Using the equation for level 3. Come again? Three 3.447713. Okay, closer to the true value. Double make sure you use the correct equation. The equation involved, which is the 16 over something. Question will be given, but you just need to know which belongs to which. Okay, take your time to digest. Okay, in final exam, you will be given this equation, Romberg, this equation. Yeah, just now, let's say this is the value that we get from OH2, K level 1. So to find I12 just now, using Romberg equation. Just now, we straight away use the 4/3 multiplied by IM, right? Actually, that one comes from this equation. Okay, I just want to let you know how to use the equation. Now, I12 following this Romberg equation. For K just now, we are at level 2. Okay, 2 minus 1 multiply by Ij plus 1, which is 2, 1. J plus 1 here equals to 2. k minus 1 equals to 1. Okay, minus ij, the one that we are doing, j 1, k 1. This is the I less accurate just now. Then over 4k is 2 minus 1 minus 1. Okay, eventually you will get 4, 1, I 2, 1, I 1, 1 over 4 minus 1. So you get 3 similar. 4 over 3, I 2, 1 minus 1 over 3, I 1, 1. Okay. Because final exam, as I remember, only this equation will be given. General Romberg equation. Okay. Now go back to the table earlier. Here. Okay, so now we know the value of each. I11, I12. Okay, second level integration, you will get I12. Sorry, I11 and I21. You will get I12. I21 and I31, you will get I22. Then from these two, going to level 3, OH6, you'll get I31. Okay. So the first challenging part is to find the points. The points and the first integration, level 1, using trapezoid. Okay. Sorry. Error here is the true error. ET, true error. The TV minus AP over TV 100%. Error here is true error, not the approximate error. Is it approximate error? I think true error. Okay. Okay, I'll stop here first. Tomorrow we will do more exercise where this slide is the one that I mentioned earlier. It defines how you get the OH2 and the OH4. Okay, I will not go into details in this. This one we are done just now, up to levels OH6. Okay, this just to summarize. You see here it used up to level K5. So you will need a set of data if to proceed up to level 5. Okay, as I mentioned earlier, trapezoid and Simpsons are only this level. OH2. Go vertically, okay, to get more accurate data. But for Romberg, it moved sideways. Few levels of integration. So you will have more accurate data instead of going downward. Okay. Sorry. Okay. Yes. Your level, usually the question will ask up to level 3 only. So you see, if to find up to level 3, let's say 1I13. In the first place, you will need here at least n equals to 4. 3 data in order for you to find up to level 3, I13. Okay, so tomorrow we will do more exercise. We will try the test, previous test and previous final exam. Okay, before I forget, now it's already week 6, right? I haven't set the date for test. Next week is already week 7, our last week, our final week. So your test, it will be on Tuesday. Tuesday. Is it okay? During class hour. We'll cover chapter 4, starting from interpolation. Starting from interpolation and chapter 5. Chapter 5, after Romberg, we will go for differentiation. That one will be quite fast, quite easy. Then ODE, ordinary differential equation. That one is a bit complicated, but that one is extended from the differentiation. Okay, so your test will cover up to chapter 5, Romberg, up to Romberg. Yes, correct. Chapter 4 and chapter 5 up to Romberg. Okay, not only Romberg, up to Romberg. Tuesday, so it will be, yes, correct, 17. Then you will leave, you will one assignment, right? I should release by this week. Assignments I might do in group. Okay, group work. I will give a set of questions, then you complete it in group. It should be in group, not individual. Okay. Okay, so that's all. Confirm test 17, class hour. Okay, thank you.